Okay, let's unpack this. Imagine you're getting on an elevator tomorrow morning, or maybe boarding a plane for your next trip. Do you ever stop to think about the last time those cables were inspected, or, if the engine parts were really maintained to spec? Probably not. It feels mundane, right? Just fixing things.
Exactly. It's the kind of thing business management often overlooks, sort of buried deep within operational costs. But what if overlooking this, the maintenance and management of physical assets is actually costing, well, vast sums, not just small change? The source material we're diving into today, it's a book aimed at executives, and it argues pretty persuasively that this often ignored area has absolutely massive financial implications.
So our mission in this deep dive is to cut through that oversight. We're going to act as your guides, pulling out the most important insights from this material. We want to give you a clear shortcut to understanding the culture, the real-world impact, and, well, the huge untapped potential of proper reliability and maintenance R&M, and why it is so much more than just fixing things when they break.
And speaking of massive implications, let's start with the sheer scale of what's at stake here. According to U.S. Census Bureau stats and a 1979 MIT study cited in the source, the R&M industry itself was projected to be a $1.2 trillion sector in the USA. That's back in 2005.
Wow. $1 trillion just for the work of maintenance. That's a huge economy in itself.
It is. But here's where it gets really interesting and, quite frankly, a little alarming. The direct cost of poorly managed physical asset maintenance and management, estimated between $500 and $750 billion in 2005 alone.
Just direct cost.
That's money directly wasted, yeah.
Uh-huh.
Fixing preventable failures, dealing with the immediate fallout of breakdowns, that kind of thing.
So hundreds of billions, just the direct financial hit from things going wrong because they weren't properly looked after.
Right, but the source points out that's only part of the story. There was an additional indirect cost, estimated at 20% of the total 2005 U.S. GDP. GDP was $12.5 trillion then, so we're talking about roughly $2.5 trillion, lost indirectly.
Wait, hold on. $750 billion direct waste plus $2.5 trillion in indirect losses, like lost production, wasted energy, disrupted supply chains. That adds up to over $3.25 trillion in total potential loss for the U.S. economy in a single year.
That's the shocking figure the source highlights. And to give you a sense of just how enormous that is, they note that this combined potential loss in 2005 ranked somewhere between the second and third largest national economies in the world. It was more than twice the size of Canada's entire economy that year. Think about that. An amount equivalent to a major G7 nation's total economic output was potentially being lost just because physical stuff wasn't properly maintained.
It's hard to even grasp a number that big. And the source contrasts this with other areas where businesses did focus intensely, right?
Exactly. Take logistics, for instance. Through concentrated effort over, 2 decades, logistics costs were reduced significantly, from 16% of U.S. GDP in '85 down to 11% by 2005. Companies also invested heavily in initiatives like lean manufacturing, re-engineering, often aiming for incremental gains.
So while they were intensely optimizing supply chains or shaving tiny percentages off production efficiency, this multi-trillion-dollar area of R&M was just sitting there, offering massive potential returns, largely ignored.
That's the core argument. The source calls it the low-hanging fruit. The potential paybacks from improving R&M were massive and rapid, measured not in years, but in months, weeks, or sometimes even moments after changes were implemented. Yet this immense opportunity remained largely invisible or, undervalued by business leadership.
And the source suggests there's a deep historical reason for this disconnect, almost like a language barrier between the managers and the maintenance folks.
Yes, it's not a new phenomenon. This gap goes back centuries, apparently. It stems from fundamental differences in training and perspective. Business management programs, like MBAs, traditionally spend very little time on physical asset maintenance, maybe just a few paragraphs in a textbook. On the flip side, R&M training often focuses intensely on how to communicate their value in management's terms, which usually means quantifying everything in dollar savings.
So you've got one group focused on high-level financials and strategy, and another focused on the nuts and bolts reality of keeping things running. And they just lack a common language to bridge that gap.
Precisely. This mutual lack of understanding, despite how reliant one is on the other, creates significant friction and frustration. The maintenance team feels undervalued, misunderstood. Management sees maintenance as just a cost center, not really a strategic function.
This takes us to how maintenance practices themselves have evolved. The source mentions a shift away from the era when equipment was simply built like tanks.
That's a great phrase for it. In earlier times, machinery was incredibly robust. seriously tough. Breakdowns were pretty rare events. So a reactive approach, waiting for something to break and then fixing it, that was common. And it was manageable. It wasn't a major disruption, and the cost wasn't the main driver. The source points out that even as recently as 2005, over 60% of businesses still primarily operated this way. Reactive.
But the 1980s brought a different focus.
Absolutely. The emphasis shifted heavily towards cost reduction, increasing throughput, eliminating waste, fueled by concepts like lean and business reengineering. Often, this led to significant cuts in maintenance personnel. And as the source highlights, the full negative impact of those decisions isn't immediate. It typically shows up 12 to 24 months down the line, maybe long after the decision makers have moved on.
So the cost savings look good on paper in the short term, but you inherit a reliability crisis later on.
Exactly. Meanwhile, starting in the mid-70s, you had new technologies emerging. Predictive tools like vibration analysis, electrical testing, ultrasonics.
That sounds like a game changer, right? Being able to predict failures?
Potentially. Huge potential. But like any tool, they're only as good as the people using them. They require training to interpret the data, and they're most powerful when combined with historical failure data. You need that history to predict how quickly a detected issue might become critical. Without that knowledge and context, they can lead to errors. Big ones.
And the source shares a memorable, slightly frightening anecdote about this very point.
Yes. The HVAC technician in Chicago back in the 90s, there was this rash of bearing failures in belted applications. Investigators tracked one massive 75 horsepower motor failure back to a technician who had been trained to tighten the belts using a very specific but totally flawed method. Tightening until the motor's current draw met the motor's nameplate value.
Wait, tightening belts based on electrical current? That seems backwards.
It is. The problem was that most belted applications in commercial buildings, they're designed to run at maybe 50% of the motor's full load capacity. So the technician, just following their training, was drastically over-tightening the belts, forcing the motor to pull way more current than it should for the actual work it was doing. The source describes finding the large wrench and pipe used belts so tight they'd literally force the motor shaft down into the bearing housing. Catastrophic failure.
Wow.
It just shows how following a technical procedure without understanding the underlying system or application can be incredibly destructive and expensive.
This brings us to another major promise of technology in R&M. These CMMS and EAM systems. They were marketed as the ultimate solution, right?
Oh, absolutely. Computerized Maintenance Management Systems, CMMS, came in the 80s. Then they evolved into Enterprise Asset Management, or EAM, systems in the late 90s, early 2000s. The idea was to apply scientific management principles, data, analysis, planning to maintenance. Promised huge efficiencies, cost savings through automation. EAM systems were supposed to integrate R&M data with other business functions like accounting and support advanced strategies like RCM. Sounded great.
But the source tells a very different story about the reality.
A much grimmer one, yeah.
Well,
Despite all the enthusiastic vendor promises and, millions spent on software and implementation, fewer than 8% of companies actually achieved the promised tremendous savings. 8%.
why such a low success rate? That's terrible.
The source points to several reasons. Often, the off-the-shelf software forces businesses to change their existing processes to match the software's built-in best practices. And these best practices are frequently designed with, say, financial reporting in mind, not the practical needs and realities of the maintenance team on the factory floor.
So instead of the technology supporting their work, the workers have to twist their process to fit the software. That sounds frustrating.
Precisely. And the source is quite blunt here. If a company already has poor maintenance practices, implementing CMS or EAM simply automates the impending disaster. It just makes inefficient, flawed processes happen faster and records them neatly, doesn't actually fix the root problem.
That's a sobering thought. And there was cultural resistance too, right, for the maintenance teams.
Definitely. Maintenance staff often viewed these systems with deep suspicion.
Yeah.
Their professional identity was often tied to being the heroes, the ones who could swoop in and fix a critical breakdown under pressure. CMM felt like Big Brother, monitoring their every move and undermining that reactive hero ego.
And frequently, the maintenance departments were given very little say or resource in choosing or implementing these systems, just told to use them.
That's a crucial point. They were told they had to use it, but weren't empowered to select a system that actually fit their needs or given adequate training and support. The source is just full of anecdotes illustrating this painful disconnect. There was a powerhouse supervisor whose team had a genuinely effective program, but they completely bypassed the corporate CMMS for actual planning and tracking. only used it to record emergencies. They felt it forced them to rush and that it was just, a monitoring tool.
Okay.
Another one, a plant where a CMMS had been installed for 5 years but was still largely empty, not fully implemented or populated with basic equipment data, just sitting there.
5 years. Wow.
And a maintenance manager who was proud of their high PM completion rate. But analysis showed the team was focused on completing non-critical preventative tasks just to hit the numbers. Meanwhile, genuinely broken equipment wasn't even being entered into the system.
Chasing the metric instead of the outcome.
Exactly. And this one really stands out. A purchasing department decided to save a few dollars by switching to a cheaper pump seal type. Okay. This reduced the seal's life from 18-24 months down to 4-6 weeks.
Oh, no.
The maintenance team became completely overwhelmed by constantly fixing leaking pumps. They just stopped entering work orders for the leaks. It was impossible to keep up. So the maintenance manager, relying on the CMMS data, had no idea that in one building alone, over 65 pumps were leaking product because no work orders were being created.
That's insane. The system was actively hiding the real problem.
Completely. And even large Fortune 100 companies sometimes had to maintain parallel manual systems because their expensive CMMCM lacked the component-level detail needed for proper root cause analysis, forcing tedious dual data entries.
So much extra work.
Ultimately, the quality of data in these systems was just highly inconsistent. From no entry at all to maybe too much daily detail, it made key programs like RCM or maintenance effectiveness reviews totally unreliable because they depended on accurate historical information that simply wasn't there or it was wrong.
So these systems, intended to solve the problem, often just made it clearer how broken the underlying processes and culture were, or maybe even made things worse sometimes.
Yeah, it was basically applying technology to a problem without addressing the fundamental process and human elements first. A recipe for frustration.
This leads us to another significant challenge highlighted in the source: the skilled workforce. Is the perceived shortage a real crisis, or is it, just a misplaced concern?
Well, it's a complex situation with conflicting data points for sure. On one hand, you have the undeniable demographic reality of aging baby boomers. Those born between, 1946 and 1964, they were the core experienced workforce. By 2014, many were nearing retirement age, and the growth in younger workers entering trades was slower.
So a lot of experience walking out the door not being fully replaced, that seems like a problem.
Exactly. Yet federal agencies like the Department of Defense, the Bureau of Labor Statistics, using census data, they often argued there wasn't an industrial crisis. They suggested the concerns were misplaced because there was sufficient overall manpower in the economy. The BLS even projected a decrease in manufacturing maintenance jobs around that time.
But that's not what manufacturers themselves were saying, is it?
Not at all. Surveys from groups like the National Association of Manufacturers, state commerce departments, they consistently reported a significant shortage of qualified skilled workers. We're talking over 80% overall, and closer to 90% for specific skilled production roles. Their concern wasn't just about sheer numbers, but about the availability of skilled individuals, people who could actually do the job well.
And what about the attitudes and readiness of the younger generation coming in?
The source notes a trend of the youngest groups spending more time in education, which is fine, but also a reported reluctance towards manufacturing jobs, sometimes citing a broken image of the industry. Manufacturers also expressed dissatisfaction with the basic employability skills of some new hires, things like attendance, timeliness, work ethic, problem-solving abilities, even basic reading and writing. They found it genuinely difficult to hire and retain people with the needed skills and, frankly, the right work ethic.
So it's not just about the total number of people available, but about having people who are both skilled and ready and willing to do the work effectively.
That's the distinction the source really highlights. While there might be enough bodies statistically, the crisis is, or was perceived as, a lack of a ready-to-work skilled workforce with the right experience and dedication. The source suggests that persistent use of outdated management approaches, like maybe pushing speed over quality or skill development, contributes to this perception and reality. Many attempts to implement new R&M programs fail and revert to reactive states precisely because the capable workforce needed to sustain those planned approaches just isn't there or isn't supported.
Who does the source believe is responsible for addressing this gap? Is it schools?
Yeah.
Government? Industry?
Studies often point to a shared responsibility, Government, academia, parents are seen as needing to promote skilled trades and training. But the source also lays significant blame on industry and manufacturing themselves. For decades of budget cuts that eliminated training and apprenticeship programs, for a failure to recognize and value skilled trades properly, not providing clear career paths. Academia, understandably, focuses on fields with clear job prospects. If manufacturing isn't seen as a viable career, fewer students pursue that training. Makes sense.
It sounds like a self-inflicted wound, really, compounded over decades.
In part, yes. And the source predicted the skilled trade crisis would become much more severe between roughly 2015 and 2020. Aggravated by early retirements and fewer experienced baby boomer mentors available to pass on knowledge to the next generation, they warned that this loss of skilled trade infrastructure, combined with global competition and outsourcing, could be a major factor in a potential decline of U.S. manufacturing dominance and a growing divide in the workforce.
Okay, so we've seen the massive costs, the historical disconnect, the challenges with technology, and this whole workforce puzzle. Let's make this even more concrete. Let's look at what happens when R&M goes really, really wrong. The source shares some compelling and sometimes pretty alarming real-world impacts.
Yeah, these stories really bring the consequences home. Consider the food processor example. Someone took a shortcut in cleaning process piping. Seemed minor, right? A way to save time or money on a routine maintenance task.
And the impact. What happened?
That seemingly small shortcut led to a regional sickness scare, product contamination. Because of heightened awareness around food safety, this triggered regional anti-terrorism protocols. Think about that. The results were widespread customer inconvenience, some individuals needing medical treatment, and a significant loss of product sales, and, crucially, long-term damage to the company's reputation. All from one seemingly minor maintenance shortcut.
Wow. That's a huge ripple effect from a single decision. What about the steel industry examples? Those sound intense.
Yeah, there are a couple that illustrate different problems really well. In one case, cost-cutting at a steel plant led them to quietly change the quality tolerances on their finished product without informing their customers. These customers were automotive companies operating on really tight schedules.
Oh, it's not going to end well.
Not at all. When they received the steel, their automated systems checked the tolerances, immediately rejected an entire week's worth of production on the spot, told the facility they would never buy from them again, and ordered the material from a competitor plant. Boom.
Just like that.
Short-term cost-cutting completely destroyed a long-term customer relationship and severely damaged that plant's reputation in the market. It's a perfect example of how maintenance decisions impact customer trust and the brand.
And there was another steel story involving repeated equipment failures. Ignoring advice.
Yes, on these large ID fan motors, critical to a furnace operation. After the first motor failed, an investigative team did a thorough analysis, made clear recommendations because there were 7 identical motors in the plant. But those findings and recommendations were ignored. Management consciously decided to gamble, thinking, what are the chances of it happening again soon?
And what were the chances? Let me guess.
Pretty high, it turned out. 3 more identical motors failed with the exact same pattern in less than 2 months. They then evaluated a 4th motor, which was a spare, and found a severe problem with it before installation. Good catch, right? But to save time, they skipped the crucial final step, the commissioning process. That check to ensure everything is truly ready before starting it up.
Oh, they skipped the final check. And I'm guessing it didn't go well.
It ran for less than 10 seconds after installation before it failed catastrophically. 10 seconds. To make matters worse, they discovered the motor they'd removed initially hadn't even actually failed. They'd replaced it based on the pattern of failures rather than confirming its actual condition.
Unbelievable.
6 turns of production were lost, all because they ignored expert findings and skipped a vital final check just to save a few hours. It highlights the cost of dismissing data and taking procedural shortcuts.
It's a clear pattern of prioritizing supposed short-term savings over long-term reliability. Just doesn't pay off.
Exactly. Another anecdote involves a grinder that had been limiting production for 18 months due to this frustrating chatter issue. The manufacturer couldn't fix it, and the plant had simply decided they had to live with it, just accepting inefficiency.
Right.
An expert came in, used condition-based monitoring technology, basically. Advanced diagnostics, spent just 20 minutes, and found the problem. A loose connection in the motor drive's firing circuit. A small screwdriver fixed it. Production limitation? Gone. Just like that.
After 18 months.
Yep. It shows how much businesses can lose by just living with inefficiency because they lack the right diagnostic tools or maybe the expertise to find the root cause.
While those industrial examples are powerful, the source also brings it closer to everyone. It warns the reader, don't read this if you are on an airplane. That gets your attention.
These anecdotes are incredibly relatable and, yeah, definitely unsettling. The source recounts experiences like seeing fluid literally pouring from an engine before takeoff, a cracked windshield and failed auxiliary power unit causing long delays, and a leaky water line above a critical battery bank that an airline was apparently living with for some time because they were, quote, lean on available aircraft.
Lean on available aircraft.
Yeah.
That sounds like a direct consequence of not having spare capacity because planes are down for potentially preventable maintenance.
Exactly what it sounds like. Then there's the story about an emergency door gasket. Maintenance had been performed incorrectly over the weekend, and a worn-out gasket wasn't replaced properly. The plane took off, began to pressurize, and an alarm sounded because pressure couldn't be maintained. The captain discovered the rear emergency cone wasn't securely attached.
That's terrifying. And the comment from the crew member afterwards.
Yeah, the chilling observation was, if the maintenance had not been performed incorrectly and the gasket had not been worn out, we would not have known the back end was not fastened properly until we hit altitude.
Wow.
A potentially catastrophic issue, narrowly averted, rooted in improper maintenance. The source says this incident actually spurred their research into FAA reports on unsafe maintenance allegations.
There was another anecdote about a missing inspection hatch on an engine, too. Something visible.
Yes, on a different flight. The captain announced over the intercom something like, "Don't mind the missing inspection hatch on the left engine. It does not impact the airworthiness of the aircraft." When the author, who was a passenger, asked how such a visible issue could be dismissed, they were told they were creating a disturbance and would be removed from the flight if they said another word.
Shut down completely.
Yeah.
That raises serious questions about potential pressure to overlook problems or silence concerned passengers.
Absolutely. And these air travel issues connect directly to the trend of airlines outsourcing maintenance.
Right, that's a big factor.
It is. The source highlights a disturbing FAA report on non-certificated repair facilities. These are facilities used by airlines, but unlike certified repair stations, they are not certificated or routinely reviewed by the FAA.
Not routinely reviewed.
No. And the FAA's findings were worrying. Minimal airline oversight. One airline had zero oversight critical maintenance being performed by these facilities. Examples of logbook errors, missed steps in mandatory procedures like airworthiness directives, incorrectly adjusted flight controls. It's a long list.
And these issues were actually cited as contributing factors in tragic accidents.
Yes, the source points to these as contributing causes in the 1996 ValueJet crash and the 2003 Air Midwest crash in Charlotte. Deficient maintenance by an outside vendor played a role in both. The critical takeaway from the source is stark. The reputation of the company is as good as its least reliable contractor. Outsourcing might reduce the direct cost you see on your books, but you often lose control over the qualifications of the workers, the quality of oversight, and the vital indirect improvements that come from having highly skilled in-house personnel who truly understand your specific equipment and operations.
So we've seen the immense cost and the sometimes dramatic, even tragic consequences of getting R&M wrong. But the source also offers a path forward, showing the power of getting it right. There's a great turnaround story about a steel manufacturer you mentioned earlier.
Yes, a really compelling case study. This company transformed from being just an average steel producer to the most profitable in North America within a decade. And they attribute a significant part of that success directly to implementing a comprehensive, proper R&M program.
How did they do it? What were the key ingredients for that success?
Well, it required full support.
Yep.
Top executives, middle management, the plant floor workers. Everyone had to be on board. It wasn't just a directive from above. They made a crucial upfront investment in implementing a strategy like reliability-centered maintenance, RCM. That helped them systematically identify what equipment was most critical and what maintenance was actually needed for it. They implemented targeted programs based on that analysis and focused on improving their workforce, primarily through managing voluntary attrition and replacing outgoing workers with people trained in the new proactive methods.
And the results were quantifiable, right? Not just anecdotes.
Oh, absolutely dramatic. They significantly increased the amount of planned proactive maintenance they did, which led directly to improved equipment availability and a higher quality end product. And importantly, this wasn't done at the expense of production. They achieved these improvements while production increased.
That's the dream scenario.
It is, and the source cites broader industry studies showing the typical benefits of successful predictive maintenance programs. like a 10x return on investment, 25–30% reduction in overall maintenance costs, 70–75% elimination of sudden breakdowns, 35–45% reduction in costly downtime, and even a 20–25% increase in production output.
Those are incredible numbers. It completely reframes R&M from just a cost center to a genuine driver of profitability and competitiveness.
That's the core insight, exactly. And the RCM mindset they adopted is key here. It's based on understanding that not all equipment is equally important, right? And not all failures are preventable or even worth the cost of preventing. It's about managing risk, understanding the probability of a failure occurring multiplied by the severity of its consequences, PF times SF. This helps you prioritize where to focus your limited resources. The source emphasizes the hierarchy, safety first, always. Then regulatory compliance, then production impact, and finally cost effectiveness.
Okay, so if a company wants to move towards this kind of success, what are the fundamental steps they need to take, according to the source? Where do you start?
It starts with the basics, but it's often overlooked, knowing exactly what you own, a comprehensive facility asset census. And this isn't just major equipment. It includes property, buildings, support systems, even less tangible but vital resources like your people, your vendors, your technology, and importantly, as we discussed, your company's reputation. That's an asset.
Including reputation as an asset makes a lot of sense after hearing the food processor and steel stories.
Definitely. It truly is. After the census, the next crucial step is prioritization. You need a clear, critical equipment list. Based on those priorities we just discussed, safety, regulatory requirements, the impact on your production or mission, direct cost, and any other specific company priorities like maintaining quality or cleanliness. It's about looking beyond simple, immediate cost savings, taking a broader view.
Okay, know what you have, prioritize what matters most. What's the next layer? How do you act on that?
Optimize and implement your maintenance strategy. This starts with PM optimization, looking at your existing preventative maintenance tasks, and deciding what equipment you can simply afford to run to failure because the consequences are low. Don't waste effort on non-critical PMs. Then, replace outdated or ineffective practices with more modern, data-driven approaches like RCM where appropriate. The source tells an anecdote about a filter PM task being done religiously every month just to meet a metric completion goal, even though the filter didn't actually need changing.
Right, another example of chasing the metric.
Exactly. It highlights how focusing on the wrong metric can lead to completely wasted effort and resources.
So it's about doing the right maintenance on the right equipment at the right time. Makes sense.
Exactly. And central to making this sustainable is continuous improvement, driven by root cause analysis, RCA. The source distinguishes between different types. RCFA for critical unexpected failures, like investigating an airplane crash process, really deep dive. RCA for looking at similar systems before a failure to identify potential weaknesses proactively. And RFA for analyzing repetitive failures, like those welding transformers in the steel mill example, things that keep breaking. The key is that the findings from these analyses aren't just filed away in a report somewhere. They feed directly back into improving your overall maintenance program. It's a learning loop.
And this improvement cycle is formalized through something called the Maintenance Effectiveness Review, the MER.
Yes, the MER. The source calls it an often forgotten but absolutely crucial step. It's the mechanism that ensures continuous improvement happens. It evaluates if the maintenance practices you've implemented are actually working as intended, helps you eliminate redundancy, and keep streamlining your efforts over time.
To make all this practical on the ground, for the technicians doing the work, the source emphasizes developing best practices, written down.
Absolutely critical.
Well,
This means creating clear, written procedures for your maintenance tasks, not just a one-liner on a work order. These procedures should outline the scope of the work, why it's justified, a step-by-step guide, the expected benefits, realistic time estimates, all the details. Having clear written standards makes on-the-job training much easier, ensures maintenance is performed consistently every time, which is vital for analysis later. It significantly helps with RCA and MER, and dramatically improves the amount of time your staff spend actually doing maintenance work, what's known as wrench time. It's a big step up from just a generic instruction like crease bearings. How? With what? How much?
yeah, good point. Speaking of wrench time, the source mentions it's often surprisingly low, like maybe 20–40% in many places. That's shocking.
It is shocking. And importantly, it states that this low wrench time is fundamentally a management issue, not necessarily a maintenance worker issue. Improving it requires effective planning and scheduling. The source introduces concepts like the workflow concept, WFC, and design for maintenance, DFM, which are essentially about organizing work processes logically around your actual equipment needs and the capabilities of your personnel. It's about designing efficiency into the process of doing maintenance, not just the task itself.
And time studies play a role here, even though they might not be popular.
They do. While often disliked by the workforce, yeah, time studies are necessary to understand how long tasks should take when performed efficiently following your defined best practices. The source gives formulas for conducting these studies reliably, getting statistically valid samples. They use the example of how different technicians might grease a motor differently, standardizing that task to a documented best practice, verified by a time study, ensures consistency and efficiency every single time.
Identifying and eliminating other forms of wasted time or losses is also critical, right? Not just focusing on the task itself, but the whole workflow.
That's a huge point. WFC and DFM help you analyze where time is being lost within your workflow. Travel time, waiting for parts, interruptions. The source provides a great anecdote about a motor repair shop. Their skilled repair technicians were constantly interrupted by customer service or management with urgent requests, pulling them off complex jobs mid-task. These constant interruptions crippled efficiency and quality, leading to a skyrocketing number of warranty repairs. The average billable time per technician was extremely low.
How do they fix that? Seems like a tough cultural problem.
The solution involved a significant cultural shift and enforcing process control. Pretty strict. All repair requests and communications were routed only through a central supervisor or planner. Technicians were shielded from direct interruptions. No one else could just walk up and pull them off a job.
A gatekeeper.
Essentially, yes. This simple change dramatically increased wrench time, improved throughput, and drastically reduced warranty repairs because the technicians could actually focus and complete jobs correctly the first time. It shows how workflow and process design impact the bottom line in a big way.
So applying those DFM principles not just to the equipment itself, but to the tasks, like batching similar work together.
Exactly. A central planner or scheduler, understanding personnel capabilities and locations, can group similar tasks together logically. Instead of sending someone across the plant to grease one motor today and someone else to grease another one nearby tomorrow, you might schedule one person to grease all accessible motors in a specific area on Tuesday morning. This batching reduces travel time, increases focus, makes better use of personnel's time, and boosts overall wrench time significantly.
Okay, but even with the best planning, random failures still happen. Stuff breaks unexpectedly. How does a good program manage reactive maintenance?
The source says you need a plan even for those unplanned events. It shouldn't just be chaos every time. The process should involve swift fault identification using good troubleshooting skills and tools to find the problem quickly. Then efficient fault rectification, fixing it properly. Then, importantly, a root cause analysis scaled to the criticality of the failure to learn why it happened and prevent recurrence. And finally, performing any additional planned maintenance on related components while the equipment is already down and accessible. Might as well, right? Developing clear troubleshooting charts, maybe based on your RCM analysis, equipment manuals, or historical knowledge, helps standardize and speed up that initial fault identification step.
And to make planning even more robust, you need to somehow blend planned and reactive work effectively. Try to anticipate the unexpected.
Yes, and that involves forecasting. Using data-driven methods, whether it's simple weighted moving averages or more complex statistical approaches like linear regression. It helps you estimate the amount of reactive maintenance time you'll likely need in a given period, and even where failures are statistically more probable based on history. This isn't about predicting every single failure perfectly, that's impossible. But it helps the planner anticipate needs, ensure critical spares are available, and coordinate external vendors proactively. Even if the forecast isn't perfect, tracking the errors helps you refine it over time. You can also use concepts like historical failure rates, MTBF, mean time between failures, or the probability of survival for a piece of equipment to help prioritize focus, especially when you're starting out without extensive historical data.
Okay, so to bring this deep dive to a close, the source leaves us with a really powerful message. Physical asset management is not just some burdensome cost you have to endure. It's actually a vast, underexplored frontier for improving a company's competitiveness.
Absolutely. It represents a significant, often untapped opportunity for boosting productivity, increasing profitability, improving safety, and building overall business resilience. But the source does offer cautions. Simply adopting the latest terminology like saying, we do RCM, or buying shiny new software doesn't automatically make a program successful. And be wary of consultants promising huge cuts if they don't have practical, real-world R&M experience. Those cuts often damage capabilities in the long run, leaving you worse off.
Right, so the key steps we've discussed, taking a full census of your assets, including reputation, prioritizing what's most critical based on risk, optimizing your preventive maintenance, using RCM principles where they make sense, evaluating actual equipment condition, developing clear best practices for tasks.
Consistently doing root cause analysis and effectiveness reviews, capturing that knowledge, training your people properly, ensuring new equipment is commissioned correctly, having a plan for emergencies, using outsourcing strategically for best value, not just lowest cost, embracing technology wisely, focusing on retaining skilled employees.
Treating vendors as partners, focusing on process over just tasks, and critically, ensuring management truly understands the value of R&M, and understanding that sometimes waiting on non-critical items is the right strategic call. These form the foundation for success.
Yes, and avoiding that trap of maintenance entropy, cutting budgets on successful programs simply because you've reduced failures. That inevitably leads you right back to that costly reactive state within a year or two. You undo all the good work.
So the core takeaway from this source seems clear. Ignoring or mishandling R&M, as illustrated by those failures in CMMS implementation or poorly managed outsourcing, comes with staggering direct and indirect costs that are often invisible to the C-suite. But getting it right, as shown by that steel manufacturer's turnaround, unlocks massive potential for productivity, profitability, and overall resilience.
Understanding this often overlooked area gives you, the listener, a powerful lens through which to view what truly drives efficiency and resilience in businesses, and where some of the most significant yet often hidden opportunities for improvement still lie.
So here's a final thought to leave you with. Given the demographic shift and aging workforce we discussed, the evolving attitudes towards skilled trades, and the historical difficulty that management has had in truly understanding and valuing this critical space, how might the insights presented here about proper R&M and the vital need for a skilled, supported workforce fundamentally reshape industry and the economy in the coming years? What happens to businesses and potentially entire sectors if these crucial lessons continue to be ignored?